Hello friends, in today's lecture we are to discuss new point of the chapter, that is public key cryptography. That is the word cryptography means that is the hidden word, right? Cryptography means your hidden words, and that cryptology is the science of the secure communication. Cryptology is a science of secure communication. That means if we have to communicate some peoples with security, then that time we have to use the cryptology concept, right? We have to use the cryptology concept. So in that cryptology there are some technologies we have to discuss. So we have to discuss some technologies or some terminologies we have to discuss. First one is, what do you mean by cheapers? First point is, what do you mean by cheapers? The codes in cryptography. The codes in cryptography are called as cheapers. Okay, the code in cryptography are called as cheapers. Okay. Second term is plain text. Second term is plain text. What do you mean by plain text? The message to be transmitted. The message to be transmitted is called as plain text. The message to be transmitted is called as plain text. Third point is cheaper text. Third point is cheaper text. What do you mean by cheaper text? The message in secret form. The message in secret form is called as cheaper text. What do you mean by cheaper text? The message in secret form is called as cheaper text. Next, fourth point is encryption. Fourth point is encryption. What do you mean by encryption? The process of converting plain text. The process of converting plain text. The process of converting plain text to cheaper text. The process of converting plain text to cheaper text is said to be encryption. Said to be encryption or enchippering or enchippering. What is my encryption? The process of converting plain text to cheaper text. If we want to convert plain text to cheaper text, and that process is called as encryption. Last, fifth term is description. Fifth term is description. what do you mean by description? The process of determining the original message, the process of determining the original message, the process of determining the original message from the encrypted message, from the encrypted message is called as decryption, is called as decryption, or deciphering, or is called as deciphering, right? Description or another name is deciphering. So there is 5 terms. We have to use some crypto system. So next point is RSA, public key crypto system. Next point we have to study the RSA, public key crypto system. Next one now we have to discuss RSA, public key crypto system. So what do you mean by RSA, public key system? Now crypto system are based on trapdoor function. Crypto system is based on trapdoors function, and that trapdoor function means that a function where easy to compute by computing the inverse of this function. What do you mean by trapdoor function? Trapdoor function is very easy to compute by computing the inverse of these functions is very much difficult, but we have to find inverse become is easy if we have to certain information is known, right? If some certain information of function is known, then its inverse is very easy to find. Now what is mean by RSA method? The scientist Ron River, next scientist Adi Samir. First scientist R means Ron River, second scientist Adi Samir, and third scientist is Leonard Alderman. Third scientist Leonard Alderman. So that R for Ron Rivet, S for Adi Samir, and last A for Leonard Alderman. Using that 3 scientists discover RSA, public key crypto system, in 1977. In 1977, that 3 scientists, Ron Rivet, Adi Samir, and Leonard Alderman, that 3 scientists in 1977 discovered the new algorithm for a public key crypto system, and that algorithm is called as RSA algorithm. So that 3 scientists discovered new algorithm is called as RSA algorithm, that was discovered in 1977, right? So there is one theorems on that crypto system. Suppose small p and small q are distinct primes. Suppose small p and small q are your distinct primes, and k is an integer and small k be an integer, Then first one is for any integer small a, for any integer small a with GCD of that small integer a and PQ. P and Q are distinct primes. A is any integer. If small a is any integer and GCD of small a and PQ, product of that two primes, GCD of that two number a and PQ is 1, then a raised to k into p minus 1 into q minus 1, then a raised to k into p minus 1 into q minus 1 is congruent with 1 modulo pq, is congruent with 1 modulo pq. So this is your first point of that theorem. And second point is a raised to k into p minus 1, a raised to k into p minus 1 into q minus 1 plus 1, a raised to k into p minus 1 into q minus 1 plus 1 is congruent with a modulo pq, is congruent with a modulo pq for any integer small a, right? For any integer small a, these two properties holds for two distinct primes p and q, right? A raised to k into p minus 1 into q minus 1 congruent with 1 mod pq, and second is a raised to k into p minus 1 into q minus 1 plus 1 is congruent with a mod pq, right? Now we have to discuss RSA algorithm. Now we will discuss RSA algorithm. So there are 3 steps for your algorithm. So there are 3 steps for your RSA algorithm, and that algorithm is called as key generation. That algorithm also called as key generation. RSA algorithm is called as key generation. Okay. So now we have to discuss that 3 steps for your RSA algorithm. So your first step, choose two distinct primes p and q. Your first step is choose two distinct primes small p and small q, right? Second step, using that two distinct primes p and q, take product of p and q, right? Second step, product of p and q, and it is called as small n, right? That value of p and q, that product you have to consider as small n. Second step, that is your third step. So for that n value, you have to find that phi of n value, right? And where n is product of p and q, right? So using that Euler phi function, you have to find that value of n, phi of n, and your n is nothing but product of p and q, and where p and q are your distinct primes. Therefore, using that Euler phi function, phi p q is nothing but phi p into phi q. P and q are prime numbers. Therefore, phi p is nothing but p minus 1, and phi q is nothing but q minus 1. That is your value of phi n. So this is your third step, and where phi nothing but your Euler phi function, right? Your phi is Euler phi function. Your phi is your Euler phi function. Now next fourth step. First step, we have to choose distinct primes p and q. Second step, take product of P and Q is nothing but n. Third step, we have to find all your 5 functions for that your value n. Next step number 4, choose an integer small e. We have to choose integer small e such that we have to choose such integer small e such that that value of integer small e will be less than 5 of n and greater than 1, right? We have to use such integer small e such that small e is greater than 1, less than 5 of n, and GCD of greatest common divisor of that integer small e and that value of 5 of n nothing but 1, right? First step, we have to choose such integer small e such that that value of e is less than 5n and greater than 1, and GCD of that value e with 5n is 1. That means small e is relatively prime to 5n value, right? And that is relative primes, that means value of small e and 5n. If GCD of that two number 1, that means that two number are relative prime. Relative primes, that means e and 5n are your co-primes. If two numbers are co-prime, if that GCD of that two number is 1, right? Next step number 5, we have to find the value of small d. We have to find the value of small d as that value small d is congruent with value of small d is congruent with e inverse modulo phi n. Next step, step number 5 is nothing but we have to find the value of such small d where small d is congruent with E inverse modulo phi n. E inverse modulo phi n. That means D is your multiplicative inverse of E, right? D equal to E inverse phi n, nothing but your D is your multiplicative inverse. D is multiplicative inverse. D is a multiplicative inverse of E modulo phi n. D congruent with E inverse phi n, that value is nothing but D is your multiplicative inverse of E modulo phi n, right? Now we have to solve for the value of D. Then solve for value of D such that D into E equal to 1, right? If D is inverse of E, then D into 1, product of D into 1 is nothing but product of D and E is 1 because D is multiplicative inverse of E, right? And here D is called as private key exponent, where D is called as, where small d is called as private key exponent, where small d is called as private key exponent, right? Now the public key consists of the modulus of n. Your phi n is nothing but public key of value n, and that the public key and value of E is your public exponent, right? So the private key consists of modulo n and private exponent small d, which is kept in secret. So therefore P, Q and phi n must also kept secret because it is used as to find the value of small d, right? That is your algorithm. Now using that algorithm, we can encrypt your crypto system. If encrypts a message, suppose your message is capital M that message consists of your numeric form using public key small e and n to obtain the cheapest text small c, as fm equal to c equal to m e raised to modulo d, right? So we have to define encryption of a code word, right? So we have to define what is meant by encryption. A message in crypto system, a message in crypto system. Suppose your capital M, right, is capital M. Suppose your message in crypto system is capital M, and that message, first that message coded into numeric word. We have to that message coded into numeric word using, we have to that message numeric into code words using public key, small open interval e comma n, using public key e and value of n to obtain a cheaper text capital C, as using the formula. So your fm value of small m from using function fm equal to capital C, nothing but your message capital M to the power e modulo n, value of C, that is coded word in your message capital M, C equal to capital M raised to e modulo n, where small e nothing but product of p and q, your value of n nothing but product of p and q. P and q are your distinct primes, so product of p and q is n, and small e is co-prime, small e is co-prime to p minus 1 q minus 1, where value of small e is co-prime with p minus 1 into q minus 1. That means the GCD of e and p minus 1 q minus 1 is 1. Same using that encryption, we will also define description. Capital M is fm raised to d modulo n, where d is number between a and 1. Same concept, we have to define decryption. Suppose we have to find if we want to find private key, in encryption we have to find public key, in decryption we have to find private key small d using decipher, to original value of message, using decipher to original value of message capital M from its encrypted version, f of capital M is capital M is f of capital M to the power d modulo n, where small d is the number between, where small d is the number between 1 and n, where value of small d is number between 1 and small n. So this is your RH algorithm RSA algorithm nothing but first step consists of we have to take different primes P and Q. Second step, take product of P and Q as n. In third step, that value of n using Euler function, find the value of phi n. In next step, we have to choose such integer small e such that value of small e is greater than 1 and less than phi n, and GCD of small e and phi n is 1. That means e and phi n are co-prime. In next step, we have to find the value of small d such that d is congruent with e inverse modulo phi n, right? That means d is your inverse of e, and then value of d and e is nothing but 1 because both are inverse of each other. So in next lecture we have to discuss the examples on your RSA algorithm. So we have to stop here. Thank you.